Hi, everyone. It's a pleasure to have you all here. My name is Ori Beck. I was asked to stand in for David for a bit. It is my great pleasure to kick this day off by introducing Binyamin Eisner from Tel Aviv University, who will give us a talk about the probability of thought, recasting the best system interpretation. Please.
Thank you. The work I'm presenting today is work in its very early stages. So most of the work is still ahead of me. So I would be very grateful to receive any kind of feedback from you in the Q&A. Of course, it's your full right to demand explanation and elaborations, and maybe I can even provide, who knows. But what I'm really eager is to receive your suggestions on how to move forward. And I shortened the talk so that I would have time to hear from you. So, I'm going to talk about the concept of probability and present a fundamental problem that various philosophical interpretations of probability have to face. Then I will present a particular interpretation, the best system account of probability, and argue that it can be extended in a way that make it a viable solution to the fundamental problem. So let's get started. One of the peculiarities of the concept of probability is its apparent dual use. It seems that probability is used to characterize objective reality. By objective, I mean here independently of the mind. And at the same time, it is also used to characterize epistemic entities like mental states or propositions. For instance, a coin is about to be flipped. The probability of heads is, of course, 1/2. It seems that I assert a property of actual things in the world. Which things, what property, those are good questions, and the answer depends on the specific account of probability you support. However, that property is what it is regardless of what I think of it. Such an objective probability is often referred to as chance. Now, suppose that the coin has already been flipped, but I do not know the outcome yet. I can still say that there is a 50% probability that the outcome is heads, but this time it seems that I'm talking about a feature of my thinking about reality, other than about reality itself. The leading interpretation of mind-dependent probability identify it with degree of beliefs or credence, and I will assume the standard interpretation from now on, and I will call it credence, subjective or credence probability. So this twofold meaning of probability stands at the center of the ongoing debate, pretty much from the beginning, on the philosophical interpretation of the concept. So we can distinguish two different strategies for dealing with this problem. The first is to reduce probability to other, allegedly more fundamental concepts. Those can either be physical concepts, such as frequencies or propensities, and it can also be epistemic concepts, typically degree of beliefs. So to understand probability as degree of beliefs means to assume that probability is a measure of how strongly you believe some proposition. How much credence you have in that proposition. This is the first strategy represented by the Lego building blocks. And the second strategy, pioneered by Rudolf Carnap, 1945, is to sort of bite the bullet and concede that there are at least two distinct concepts of probability, one epistemic, the other is not. But there is also a third approach, and this is the approach I would like to take today. On the one hand, I agree with Carnap that the two uses of the concept, the epistemic and the non-epistemic, are both fundamental. We should not try to reduce one to the other or to explain one in terms of the other. On the other hand, I reject the claim that there are two different concepts of probability. Instead, I strive to provide an interpretation of probability that does justice to the two contexts in which it is applied. Such an approach immediately gives rise to the possibility of treating the dual use of the concept not just as a problem to be solved, but as one of the main hallmarks of the concept. And I think it's a great advantage for a theory if it is able to explain the dual use of the concept without deeming a significant part of everyday language imprecise. The best system account of probability can be seen as a refinement or sophistication of the relative frequency interpretation. So before I introduce the best system account, it would be helpful to say a few words about what is wrong with relative frequency interpretations. Frequentism is perhaps the least metaphysically pretentious explication of objective probability of chance. Take a set of all the outcomes of a specific coin being flipped multiple times and assume that the proportion of heads among them is 50%. Frequentists argue that to say that heads has a 50% probability is just to assert that proportion, nothing more. And since nobody denies that such a proportion exists in reality, this interpretation has the advantage of avoiding any controversial or suspicious metaphysical concepts, such as counterfactual or propensities. Unfortunately, this interpretation, the simplest version of it, is clearly wrong. And what is wrong with frequentism is that there are cases when we clearly want probability to diverge from frequencies. For example, consider a fair coin that has been tossed only 10 times and then perhaps destroyed. And it happens to landed heads 9 times out of the 10. Those things does happen. In such case, we would want to say that although the observed frequency of heads is 90%, the chance of heads is still 50%. And another related issue is the famous single case problem. We regularly apply probability calculations to many events that seem unrepeatable. For instance, we talk about the probability of a candidate winning an election. But since this is a single and allegedly unrepeatable event, the frequency of winning is either 100% or 0%. And the best system analysis, which I will present now, is one attempt to modify the relative frequency interpretation in order to solve those kind of problems. Since we are not all familiar with the best system account of probability, especially not the specific version I am building on, I will now briefly present the original theory by David Lewis. Then I will consider some modification of the original theory done by Karl Hofer. And finally, I will suggest my own extension. So according to David Lewis, just like frequencies, objective probability or chances, as I will call them from now on, are facts that supervenes on patterns of actual events in the full history of the world. However, those patterns are not always frequencies. For Lewis, the essence of chance is its ability to serve as a guide in cases of partial ignorance. And this is a common situation since we are almost always lacking at least some relevant information. So the requirement that objective chance must be able to guide rational belief is codified by what Lewis called the principle. Mysterious name. And this principle states that the credence of an ideally rational agent in a proposition A, represented by CR here in the equation, giving the knowledge that the chance of A is X, must be also X. So, for example, if I know that a coin has a 50% chance of heads, my credence in the proposition that the outcome will be or was heads should also be 50%. This is a very intuitive idea. The chances should guide our credence. Otherwise, why would we ever be interested in knowing them? It is very difficult to come up with any other satisfactory answer. So, to say that a coin has a 50% chance of heads for Lewis is to say that there are some facts about the full history of the world, such that knowing those facts would dictate to a rational agent a credence of 50% in the proposition that the outcome is heads. Lewis based his interpretation of chance on his account of laws of nature, and as a Humean, Lewis maintains that laws of nature are nothing but a good summarization of events in the past, present, and future, in the form of a deductive system, of course. However, there is more than one deductive system with theorems regarding the actual history of the world are true. So Lewis suggests two theoretical virtues that we should be aiming for when we choose the best system, so-called, of generalization. First, simplicity, how compact and perhaps user-friendly the system is. And second, strength, how much information the system codifies. So there is, of course, a trade-off between those virtues. It is easy for a theory to cover a lot of terrain by giving up on simplicity. And it is also easy to be very simple without saying much. The challenge is, therefore, to find the sweet point of balance here between those two virtues. And the system that optimally combines the virtues of simplicity and strength is the best system, and laws of nature, according to Lewis, is just the theorems of this best system. Now, Lewis says, we allow probabilistic theories into the competition. So those theories is just a theory that include not only regularities of the kind if f then g, but also regularities of the kind if f then the probability of g is x. We allow those theories in since they too offer good and compact summarization of facts. And we are now in a position to introduce a third theoretical virtue, namely fit. In theory, we can calculate the probability of the full history of the actual world in light of any specific probability theory. We cannot execute it, just computation in real life, but in theory it is possible. And the idea is that the more probable the history of the universe is according to a theory, the more that theory fits our universe. We assume that the best system includes such probabilistic laws, and the definition of chance follows directly. The objective chances are what the laws of the best system state them to be. So Lewis claims that he can see dimly but well enough why knowledge of those chances should constrain rational credence. And if you are interested, Karl Hofer in his book developed a rigorous proof for that, and I think it's convincing. On the other hand, if you feel that the definitions of simplicity, strength, and fit that I gave are, and especially the idea of balancing between them, are a bit vague, you are absolutely right. This is a famously weak point in Lewis's theory, and I will not address it in this talk. Simplicity, strength, and fit allow for objective chances to diverge from actual frequencies, since maintaining the simplicity and the overall fit of the system is also valued. For instance, let's say that the frequency of a radium atom decaying in 1,000 years is 0.50001. For reasons of simplicity, the law in the best system may round this frequency to 50% instead of citing the actual value. This is how the best system approach solves the main problems of frequentism. Now let's move on to Karl Hofer's version of that theory. Karl Hofer, in his book Chance in the World, suggests a modified version of the best system account. Two main theses of Lewis's view are preserved. First, to say that the objective chance of event A is X is to assert the existence of a pattern in a group of events. And second, this pattern must have a unique feature. It must be such as to make the adaptation of a particular credence rational, in the absence of better information, of course. Part of Lewis's account are rooted in his Humeanism across the board about all modal things, counterfactual, causality, laws of nature, and so on. We can give up on those parts, Hofer says, without losing too much. He argues that contrary to what Lewis holds, the connection of chance and laws of nature is unnecessary. Even patterns that for some reason do not deserve to be considered laws of nature could still qualify as chances. But to achieve that, we need to modify a key point in Lewis's account. First, we have to know that each and every frequency is defined relative to a chance setup, or as we usually call it, reference class. That is a set of conditions which specify an experiment. For Lewis, the chance setups necessarily include all historical events up to the present time. But since we give up the connection to laws of nature, chance setups can also be relatively small and local. It can, for example, include only the outcomes of a particular coin being flipped multiple times. An inevitable consequence of this modification is that we now have literally endless probability functions that link a chance setup to outcomes. Endless patterns that can be recognized, and surely we cannot consider all of those patterns as chances. So here we need to accommodate Lewis's idea of the best system to our needs, and no, this This is not meant to do that. Okay. Imagine a series of books, each of which is called a Book of Probability. Yeah. Don't look it up in the library. I invented the name. In each book, there is a list of propositions specifying chance setups and the probability of an outcome in those setups. For instance, radium elements we have decaying in 1600 years, and the probability is half. And we have coin toss heads, coin toss and outcome heads, probability is still half. Rolling a dice, outcome even number, probability is half, and so on and so on. We have endless of those chance setups and outcomes. One of those books, allegedly, has a maximal combination of simplicity, strength, and fit, and the probabilities written on that book are what we call chances. Giving up the connection to natural laws allow us to talk about chances of event of like flipping a coin and not just radioactively decay. But this is not all. Hofer claims that even mundane events like the 9:37 morning train arriving on time can also ground chance. We should look at the patterns of arrival times, he says. Do they appear random over time? Is the distribution stable? If the answer is yes, the best book of probability may include details about train arrival patterns as well. The everyday talk about objective probability in such cases is not mistaken after all. So, including trains and coins in the best book of probability requires Hofer to make a small retreat to a position that some of us may find uncomfortable. The best book of probability is only the best relative to our preferences and needs. We are the ones that are interested in train arrival times, in rounded chance numbers, and so on. So chances are indeed objective in the sense that they are to be identified with patterns of actual events, but those patterns are chosen from many alternatives according to contingent criteria, reflecting only our particular preferences. So now I believe we are ready to make one more step forward. This is my proposal. Offer significantly expand the scope of Lewis's theory. Chances now can be identified not only with patterns in huge collection of micro events, similarly to the case of laws of nature, of natural laws, but also with patterns of medium-sized collection of macro events, like a collection of train arrival times. And I want to explore the possibility that those chance makers collections also include collections of credence, that is, of mental states. At first glance, it may seem like a move that leads to a vicious cycle, since, as we remember, chances are the data that we are supposed to plug into the principal equation in order to determine our credence, not the other way around. However, as Bayesian knows very well, it is a demand of rationality that some credence, ours or others, should affect our other credence. So, as a first candidate, I propose a well-known Bayesian principle. It is the principle that states that we ought to defer to the opinion of experts. Experts are, in that context, these are rational agents who have more evidence than you regarding a specific matter. One version of the principle regards cases where experts have a disagreement between them. And the principle says that your credence should be based on the frequency of experts' opinions. For example, if 5 out of 10 experts believe that generative AI is a serious existential risk, your credence in that proposition should also be 50%. The principle also requires that the group of experts you based your credence on be random sample of experts, and if most experts belong to one discipline, for example, the principle does not apply, but this is another story. I think that we can redescribe this principle in terms of the best system account as follows. There are patterns in credence of rational agents. Those patterns are stable over time and randomly distributed, and there are good reasons to use them to guide our own credence. Those characteristics suggest that it is quite possible that this credence has a chance. That is, they may appear in the so-called best book of probability. Let's go back to the books of probability then. Maybe in the last line we can find chance setup, credence of experts about AI. In the outcome, we can find generative AI is a serious risk, and the probability of that is 0.5. This is, of course, only one example. How much of our credence is really derived from the patterns we recognize in someone else's credence? I would argue quite a bit. Credence has patterns, which are, in parts, what makes experience so critical in problem solving. Think about the times when you ask yourself, how would I have acted in similar situation, or what would my mother say about this? In those cases, you try to derive a credence based on what you know about other people's or yourself in other times' credence. And thus, in terms of the best system account, you treat credence as having an objective chance. So, back to the picture I drew at the beginning, the frequency interpretation of probability is considered the paradigmatic example of reductive interpretation, since the chance makers are frequencies of physical events. However, I think that after the modification of Lewis, Offer, and me, mental events may also be chance makers. The best system interpretation in this version explicates a concept that can accommodate both subjective and objective probability. Thus, it is much better suited to the way in which the concept is used in practice. I think this is a significant point in favor of this interpretation. Thank you so much.